Hello, dear students. Time MC, sound working. Ужас. Sorry, but at least I'm sure sound exists. Now, yesterday for me, who knows when for you, in previous class number 9, today we have class number 10, we been talking about the engines and about the fields of engines application, and I have shown you this chart. These curves means limitations of aircraft existence, aircraft flight possibility in different conditions of altitude, heights, and speed, given here in Mach number typically. Such diagrams exist in different sources. I said you in our sources I get used to see it in a bit different way. We'll show you what it looks like, and practically the same. Little bit different curves, more detailed, let's say. And today we are talking not about engines or airframes or whatsoever partial. We need to talk about the general principles of aircraft design. Now, as I said, you first let's see this diagrams of aircraft existence, and there are different areas of what is outside of this curve. I hope you do remember. It means flight is not possible there, whatever propulsion system we are going to use, for instance, because of lack of lift. Or, for instance, in this area, one of the most important reasons are aerodynamical heating, overheating of structure, and losing the strength due to this, and their vibrations, flutter, buffeting, and so on. Dangerous phenomena which may be resulted in immediate crashing of airplane. I'm not talking about fatigue strengths, I'm talking about so-called aeroelasticity phenomena. And the same practically regions, the same curves, but more colorful. And do pay attention. Whether first picture or second, doesn't matter. Here is red one. It's lack of lift. Outside of this area, flight is not possible because of lack of lift. Curve number 5 here. High temperatures and overloads, they are here near the Mach number line, near Mach number axis. First, high temperature, first curve is here, that one, 6 here. Temperature, second one, due to limitations of speed. Third is overloads. No, limitations of speed, it means due to be truth, due to much speed to great speed. Loads to the structure will be greater than ability of structure, specific loads, which, as I explained you, depends on the faster you fly, the less area of wing you need, but you have the same lift, and with the same lift you have less wing. And it means that pressure, aerodynamical load on the each elementary area of the wing will be much greater. And at some moment this pressure will be so high that it's not able to work with any material at all. Any material. I'm not talking about the most efficient materials for flight, but any material. Plus to these vibrations, due to vibrations, flutter, you see what here is curves about them. No, this curve may be moved a bit, curve number 4. It's maybe somehow solved due to changing in structures, additional elements in structure, but curves about aerodynamical heating, about the overloading due to the speed and so on, it's already unsolvable matters. And I promised you to show you so-called aircraft engineering anecdotes. We have already seen some of them, hundreds of them in internet, starting from the simplest one and finishing the more detailed one. You see, we will not stop on them much, but maybe today we will use it time to time, those funny pictures. And it's so-called dream aircraft. Dream aircraft, or what may happen to aircraft design in case one of direction in team of designers will win. For instance, you see what on the top picture. In case we think much about weight, it will be something made of paper and sticks, wooden sticks, for instance, and it's enough. If we're much concerned in aerodynamics, onto aerodynamics, you see something like flying wing without any place for payload. If we think how to reduce our difficulties while manufacturing, let's make everything rectangular, simple, better made of wood, and so on. Each of these picture maybe explained like in details, because really they are written by those who understand aircraft engineering. No, let's not stop on them much. Let's talk about principles of design. Here is approximate explanation how at all stages of design, how it's happened. No, you might see the first is a serious stage of so-called conceptual design, next preliminary design, and finally detailed design. What does it mean? Airplane pass through some stages, some iterations of design, and before we really goes into designing something, first we need to understand what we do really need. Not we, but our customer, who demand us a new aircraft, for instance. And those stages of design, first one, conceptual design, it's like our reply to the customer. It's to the customer or to the need of market. In the most general way, we are proposing different decisions as a reply, I said, to the need of society or some company, for instance. And in this case, it's possible to have a lot of so-called different concepts. Conceptual design may be completely different. Variants of airplane may be extremely different by aerodynamical scheme, by amount of wings, by the all these outer features we've been talking about in one and classes. And these concepts, they are necessary like to stop on one of them and to continue so-called preliminary design, which already more detailed. It's not creating of aircraft design yet of real parts, but it's at least the no major elements of geometry design. We understand outer sizes. It comes at this stage. It comes about aerodynamics of airplane, and it comes about the weight of the airplane already, so-called zero weight iteration. And after airplane looks already like the whole airplane, by the word it's like sub sub something is here. You might see here the computational models for aerodynamics, for analyzing of different variants of concepts of airplane. What I've been talking about, that at the first stage it may be some conceptual decisions, and these decisions, they are not realized in details. They are not much studied in details, but at least they are analyzed from different point of view in order to stop on one of them, which will be acceptable in terms of design, level of science that exists? Are we able to calculate it at all those things or not? Maybe it will be too complex. Level of manufacturing, are we able to produce it, or it will be not producible or much expensive in manufacturing? And operating, maybe something is ideal from the point of view of aerodynamics, but it's completely inconvenient in operating. And these contradictory demands of design, let's see, next, after you stop on one of them, you need somehow align into the one structure of the airplane. Once again, do start to explain you, no, not explain, but at least I will list them, so-called principles, general principles of aircraft designing. I not will that type it, maybe time to time I will explain something again with drawings of my, do forgive me, ugly pictures. First, no, I should of course to start from the zero importance matter, like the most important matter. I said you idea fix of any designer, normal airplane designer, but we will start with the first. First, no, actually not even the first, but what we purpose it, no, how we select that or another decision, how we pick those decisions. While designing, it's important to realize minimization of costs for everything. What does it mean for everything? Minimization of costs and time for design, for manufacturing, and for operating of the airplane. And how to think in this direction. No, above the all, as I already said, at the stage of conceptual design, you made some propositions, have stopped on one of them, and next. Next, we should understand so-called flight performances of the aircraft. What it comes about. First, purpose of the airplane. What it for? No, I prefer to talk about civil airplanes like cargo or passenger for transportation of people. No, whatsoever purpose of airplane. Maybe it's fighter, maybe it's bomber, maybe it's cargo airplane, maybe it's agricultural airplane, maybe it's airplane which fly somewhere where we have no airfields at all. So first you need understand the flight performances of this airplane, the purpose of this airplane, flight performances of this airplane, and the environment of its operating. What does it mean in more details? Flight performances for different purposes, for different classes of airplanes, they may be a bit different, but the most important of them, of course, speed, range, maximum possible altitude, maximum possible height of flight. So this height of flight, I hope you do remember, it's next resulted one of decisions that it's important for you, what type of engine to choose. No, and the same with the speed, by the word. So purpose, speed, range, and height are the very first flight performances. And quite clear, there are a lot of additional ones depending on what is your purpose of airplane. Now let's think that we're talking about the passenger airplane. What is the most important factor now for you to understand that will determine a lot of additional elements in design? How many people you need to transport? Next, what did I say about the environment of operating of airplane? How many people for one flight you need to transport? Yes, but where you going to transport these people to? Maybe it will be between megapolises, and maybe this airplane, no, like someone said you 10 people, okay, but there are business jets, 10 people, luxury airplane, little flying palace, do forgive me, no, like flying cab, flying taxi for billionaires, or it will be so-called light airplane to transport people from village to village. And in one case, it's no, start, take off, and land to the normal airfield. In another normal airfield, I mean concrete runway. And in another case, it's dealing with the ground airfield, somewhere там, grass field, for instance, or desert near this village somewhere in Africa. That is important. So starting with your flight performances and understanding of purpose of airplane, you start thinking about airplane main features. And in this case, you deal with demands of aerodynamics already. What does it mean, aerodynamics, in this meaning? You need to select aerodynamical scheme of airplane. I hope you already do remember what is it. No, in all the pictures that you see right now, it's represented so-called conventional aerodynamical scheme. But at least you supposed to know already the canard, 3 planes, combined one, all other like convertible. What is next? Tailless, flying wing, and so on. The weirder one, let's say, the more complex it will be in design process because they are not usual, let's say. So demands of aerodynamics. Next, demands of aerodynamics also may be different depending on the purpose of aircraft. What these aerodynamics should be focused on. Mostly when we talked about aerodynamical matters, I said to reduce drag, we're interested to reduce drag and so on. Yes, why we're interested to reduce drag? For reducing the necessary thrust and for saving the fuel. But it's important only in case you are working with civil airplanes. If it comes about military airplanes, this point is not at the first place, and aerodynamic will be focused on the providing the good maneuverability of airplane, how quickly it may rotate, turn, and so on. So it's another story. And plus to this, look, when it comes about passenger airplane, we're much interested in reducing of noise because of, for comfort of passengers and for sustainability problems solving. Airplane should be not noisy, not harmful, and so on. And when it comes about military airplane, the considerations of so-called stealth problem at the first place, not even noise. How noisy this airplane is, it doesn't matter. It's more important, if it's bomber, for instance, or strategic bomber or front bomber. It's more important how visible this airplane on radar screen. No, and so on. So aerodynamics, like someone say, the more the better, the less drag the better, the more lift the better. Not, certainly not. But whatsoever, we of course should strive to the increasing the characteristic which is called lift to drag ratio, or which is called aerodynamical quality. By the word I have found them, I will jump. Do forgive me. My favorite story to jump. I found them, but I do not remember where them now. Wait a second. Here is. I said you at least some real polars I've seen, and now you see real charts of coefficient of lift versus coefficient of drag, and it's for very popular airplane. Sorry, forgot to prepare that photo. I trust you may recognize it. In our country, it's got name something like Mace airplane. Why? Because Antonov number 2, after Antonov second. very popular since 15 years of previous century. There are new modifications of them with another engines and so on, flying all over the world, even by now. Why Mace airplane Kukuruznik? Because of one of the main purposes of this airplane in Soviet Union was dusting the crops, crop duster, let's say. No, of course, it's too big for crop duster. It's been used in different purposes, and these purposes were, for instance, like training of future paratroopers, beginners, next transporting of people, medical version, and so on and so forth. But right now, you see this airplane real polars in different flight configurations, like with flap down, with flap hidden, with different elevator positions, and so on. And by such diagrams, it's possible to understand what is the best angle of attack for flight. For instance, if we draw here tangent line, what will be in this diagram? -4. No, whatever, but do forgive me, what here is. I draw the straight line, and where it's touching this polar, -4, on this curve, somewhere between 2 and 4, no, and so on. So, however weird is it, it's important to understand this aerodynamical performances. But it's already when you have ready design, it's possible to determine. At the conceptual stage, not conceptual, but this preliminary stage, you have only understanding that your class of airplane, for instance, may be in the range, for instance, quality of 8, 10, and of quality 15, if it comes about military airplane. Yes. So aerodynamics. First, demands of aerodynamics. Lift to be provided, necessary lift, and the drag should be minimized, yes, but with some variance, Next, power plant. Power plant, we talked two previous classes, what it for. Power plant, it's necessary to provide, sorry, touched occasionally some wrong place in the screen. Power plant provides thrust. No, those pictures with forces acting to airplane, I afraid I'm already knocked into your brains, those pictures and all those formulas. I hope you will remember it, at least for some period. And thrust directed forward and responsible for this forward flight, it should be enough for providing the cruise flight. And moreover, power plant should provide you at least takeoff. No, and of course, for the passenger, for civil airplanes, amount of landings must be equal to amount of takeoffs. You understand? And to have takeoff, you need power plant more capable, more powerful than for cruise flight. No, partly this thing may be this problem may be solved not due to the power plant at all. I hope you do remember among flight controls we have so-called high lift devices, which helps to solve problem of thrust lag during takeoff. How this problem appear at all? Like take it in mind next. Like maybe just take the more powerful engine on board or use more engines. Why we forced to use high lift devices? Yes, we may. Yes, but do remember during takeoff, for instance, you need the force of 3 engines, for instance, of 3 such engines, and during the flight, it's enough to use one of them by thrust, for full, let's say. And what? And during all the flight, the flight, and it comes about some dozens of years next, if we're talking about the passenger flight, you need to cruise to travel with this extra weight on board. extra weight resulted in extra fuel resulted in increasing of cost, increasing of harm, damaging exhaust from airplane, and so on. It's like the endless ring of problem appeared due to the wrong decisions. So power plant should be quite enough for cruise flight. For takeoff, it should have some reserve additional amount of capacity, and partially we solve it due to power plant, partially we solve it due to another decisions, for instance, using of high lift devices on one matter. On other matter, during the cruise flight, power plant is used to provide thrust, yes, but it also have some auxiliary purposes. In particular, what auxiliary purposes might be? Anti-icing system supporting in flight. In military aircraft, usually it's solved not due to the engine, but due to using of special electrical heaters and so on. In passenger and cargo airplane, it's more popular decision to use hot air from engine. When it comes about the conditioning system, for instance, or some another systems, power plant also take part in all these in all the systems. And one important consideration of power plant, it should be, once again, it should be enough for cruise flight with some little addition. But one more important consideration of power plant, if we're talking about the passenger airplane, it should consume as much as less as possible, as only possible, the fuel. Because we do remember that our secret aim is to provide the minimization of costs in three stages of airplane life, while designing of the airplane, while it's manufacturing, and while it's operating. And operating lasts for dozens of years if it comes about civil airplanes. And each additional gram of fuel for a kilogram of let it be for kilogram of lift, for portion of lift, it means that you multiply it to the period of flight, to some hours, and you multiply it also to their years of operating of this airplane. Huge amount of cost may be saved to a saving of some grams of airplane during its operating. Next, during design, you will spend additional money for saving weight design, and during operating, then you saving hundreds, thousands of the same money. Next, no, for military airplanes, this consideration may be a bit different, as I'm already said it. Next, demands to so-called onboard equipment. First, it's necessary to understand what we understand as onboard equipment. Look, airplane need equipment for navigation. It's now a lot of different devices which helps to understand the heights, the speed of flight, to navigate. No, you know that in old versions of flights we have even special engineer on board who calculate the course. Such engineer was responsible to understand where we are in flight, whether it was passenger airplane or it was cargo airplane or military airplane. No, if it not comes about fighters, of course. And navigation equipment, it's one thing. Next, we have equipment to communicating inside of the airplane, and of course with ground, with dispatching services, with airport, and so on. So-called radio equipment. All this equipment, do forgive me, it doesn't work on steam. Yes? No, it was the sort of joke, do forgive me. It should work on electrical energy. It means that on board you need a lot of equipment that provide you electricity. Partially this problem may be solved due to power plant. Partially you have accumulators. You understand that in case of problem with engine in flight, if you depends only on engine, for instance, in this meaning, you losing like no, not controllability, of course, of airplane. You might lose all the communication, all the idea about navigation, where you are, and so on. Uh, no, the truth also that not all of these devices work on electrical energy. Some of them they are like safe living. They able to live independently on electricity supply. Uh, Next, besides of all this equipment, like for navigation, for communication, for providing, for supplying the electricity inside the airplane, for crew, passengers, and communication and navigation devices. Plus to this, we have a lot of equipment that immediately related to the payload, to the kind of payload. Not if we're talking about passenger flight, about passenger airplane. At least on board you need toilets, kitchen, and armchairs, sitting chairs, at least, in order no, to accommodate all the people inside. Plus to this, you have some lifting devices, for instance, for luggage. Maybe not, maybe yes. Plus to this, you have additional devices uh, for emergency, no, emergency expelling, emergency escaping from the airplane, and a lot of additional equipment which is necessary. Maybe it's not even necessary for each flight, but for emergency situations, it's necessary to be on board each flight. And all this also has significant weight. Don't forget about this. Uh, Next, demands of so-called safety and reliability. Safety, reliability, durability, and so on. It's so-called airworthiness. No, the joke that you have already heard today, amount of takeoffs must be equal to amount of landings. But there are rules of airworthiness in the plainest word. Of course, for civil airplanes. For military airplanes, not compulsory, and moreover, they have choice in this meaning. They have so-called ejecting seats, you know. So reliability and safety, what it may depends on. No, considering how much complex technical system airplane is, what it depends on. We may watch each particular system of airplane and talk about some individual problems with the system. For instance, when we're talking about the equipment and the reliability, certainly it doesn't come about strength of this equipment. More probably, it depends on how reliable it no, in terms of inner damages, and in terms of if it comes about some electric equipment, and in terms how safe, how it's protected from some electromagnetic effects, for instance. When it comes about the airframe, about aircraft structure, what it comes about? It comes about the strength above the all, of course, quite clear that airframe of aircraft, of airplane should withstand all the loads aircraft deal with. And I'm already said you there are so-called norms of airworthiness in different countries. They may be different, no, different documents may be, but most of them they are subordinated to demands of ICAO, International Civil Aviation Organization, most of them. And if even country has the inner documents about no, inner directive documents about airworthiness, they must be somehow aligned with documents of ICAO, or else you may fly it only with your airplanes. You may fly only inside of your country. And where I stopped it? Sorry. Now, the norms of strength, the no, demands of strength. Cruise flight, one scheme of forces, takeoff, another scheme of forces, landing, normal landing, one more scheme of forces, no, hard landing, or some maneuver of airplane. Distribution of forces are different. Distribution of forces are different. Loading is different, and so on. How to design airplane that correspond to all these demands without compromises. Actually, while calculating the strengths, I'm already said you, strengths engineer, strengths analysis engineer, they check all the cases. They work with so-called overloads. In cruise speed of passenger airplane, we have no overloads. All the forces are equal to each other. While takeoff, it's no, accessible overloads. How much you may stand, do forgive me, no, without significant uncomfortability, uh, inconvenience, let it be, if I'm not able to pronounce that word. How much you may stand. Overload, you understand, of course, it's how much the load acting to you related, it's like ratio between load acting to you to your weight. No, in airplane, loads acting to the airplane to weight of the airplane. While takeoff, lift should be more great and quite clear that we have overloads. Values of overloads like 2 and 3, it's already extremely uncomfortable for normal people, just for people. For professional pilots, for military pilots, values like 8, 9, it's practically already something extreme. Even for cosmonauts, it's too much for astronauts. And 8, 9 overload, it's maybe resulted in unconcisioning the pilot or passenger. Passenger may just maybe die because passenger is not trained person, it's not a military pilot, yes. So overload should be as minimum as possible, but in our calculating cases, so-called, these overloads given a bit more than necessary, and moreover, we additionally work with so-called coefficients of safety in order airplane has some excessive strength. But what does it mean, excessive strength? The more the better? No, remind you, where is it? Not obvious here. No, what here is stress group. Да? No, above the wall, why it looks like double T. I hope you do remember how I explained it you about the typical cross sections of some elements of airplane which deal with bending moments. That is more effective cross sections. And from the point of view of those who calculate the strength, that is the best decision, of course. Like, what about the strength? The more the better. Oi, because the more material you use, the more strength will be resulted in more material. The more material, the heavier airplane, and what next we will see. No, and so on. So these demands of durability, reliability, and safety of flight, on one hand, it comes about strength, but not much strength. Sufficient enough strength with little coefficients of safety, let's say, but not much than necessary, or else you have extra weight. When it comes about reliability in general, what should be said also about those devices and so on, how to provide um, reliability, for instance, reliability of phone, of smartphone in your pocket. Not even reliability of smartphone, but reliability of your communication, I don't know, to parents, for instance, that you always have access to your parents due to the phone, to the mobile, no, the cell phones, mobile phones, smartphones, and so on. What is the most obvious way? Have two phones in pocket, or even three phones, who work even with different operators. Yes, uh, decision looks maybe inappropriate for real life, but even in real life, some of us have a couple of phones simultaneously, a couple of gadgets in different pockets. And in airplane, the problem of reliability may be solved also in such a manner. Normally, airplane, like we will said even since our first year, in airplane is doubling and reserving, standing by everything, every system, every important system when it comes about control system of airplane, the communication systems of airplanes, and so on, doubling and resolving everything, including the pilot. But that is the reason for airplane, uh, big airplanes, modern airliners, which have, do forgive me, practically all the flight controlled by autopilot. Maybe only during landing, takeoff, they are working with pilots. But why they have their second pilot? What for? Is it enough to have the only pilot if they most of time this pilot practically spent watching the work of autopilot? It's enough. But why there is one more pilot in the cockpit? Because of demands of safety and reliability. How these demands may, for instance, affect the our plant, I'm already said you. May you take the only, what for passenger airplane, the only engine of greater capacity. May you? Yes, but demands of reliability say you better should take two, less in capacity, but two of them. And each of them should be able to provide some, not efficient, but flight, cruise flight, one of them, to continue flight, or at least to continue flight for some period until you may land somewhere. No, and so on. These demands of reliability and, I said, and safety and durability of flight, they are in must be considered in different aspects, and they are too much wide in this list. Next, uh, demands of manufacturing. In our country, it's called structure technological efficiency, according to our standards. In international society, in English talking countries, they have such concept of design for manufacturing. What I pronounce it like the whole word, yeah? And it's that is one noun, the only noun. Design for manufacturing, design for assembling concept. What does it mean? All the elements of airplane and airplane pieces and airplane as a whole, they should have the most efficient, the highest level of design for manufacturing. It means what? in the plainest word, it means conveniency of airplane in manufacturing, conveniency of producing of each particular part, individual part, conveniency of joining during assembling, conveniency of testing, and so on. And it comes only about period of manufacturing of airplane. So design of airplane, while designing, it's already like thinking forward for manufacturing, future manufacturing of airplane in order to save costs while manufacturing and lead time preparing the facilities to manufacturing of the new airplane. What it's for, no, what it's about, that those who design airplane, they work in tight collaborations with those who keen on technologies, keen on manufacturing matters. Like they goes hand in hand in order to design airplane that will be really realized in manufacturing. These rules of design for manufacturing, it elementary explanation of them, it takes maybe some lectures. Next, we'll talk about it, but like in the zero iterations also about these rules of design of manufacturing for manufacturing. Once again, it comes about the adaptability, let's say, of elements of aircraft to the demands of manufacturing, to save time of manufacturing, money for manufacturing, to save time of preparing of manufacturing of this design, and so on. The same demands may be given for operating. No, somewhere I've seen the picture, ideal picture from point of view of those who operate the airplane. What here is maintenance group. What do you compare what manufacturing group, production engineering? Yeah, what it's called. Airplane looks like this. The simpler the better. Here is the more simple the better. Everything is straight, made of wood, and just stick it one to another. And in a point of view of stop jumping, please, of those who maintain airplane. What does it mean maintain airplane? They support life of the airplane on the airfield, and they are not testing it, but it's inspecting it, checking. These checks complex, and there are 4 different types of checks, and one of group of this check may be repeated in some years, for instance, but before each flight and after each flight, there is a special group of people who making check each flight. No, things like twice per flight, like before flight immediately and after flight immediately. Checking group, inspecting group goes all over the airplane and watching, checking everything by specialist. But they are not just dancing around the airplane. They need to have access in different places of airplane because they need to check systems of airplane, control system, electrical system, hydraulic, and so on, all the places. Plus to this time, they need to have access to some important places of structure in order to make sure that structure is not subjected to corrosion, to some fatigue problems, and so on. All these demands structure of airplane have little doors, as it's shown here. You see openings in different places of the airplane. It should be a lot of places where they have access inside of airplane. And all these places, of course, each such cut out in the structure of airplane, it's also resulted in what? Where we have cuts, we have to increase amount of material around. If regularity of structure broken, it's foiled, not complied. it means that you need to reinforce this place. Reinforcing this place, it's resulted in increasing the weight of structure of airplane. Increasing the weight of structure of airplane, it's resulted in increasing of fuel for each flight. I'm already maybe perforated your brains with those stories. I need you to remember this permanently, like keep it in mind. What it resulted improving in uh, improving in the maintainability, for instance, by the word, this word maintainability and the word manufacturability, production ability, assemble ability. It comes about those design for manufacturing, design for assembling, and design for maintenance also. All these properties of structure, which provide convenience in manufacturing and in operating, they resulted in overweighting of structure. But without providing these properties, it's not possible to provide normal operating life of the structure. Next, no, in operating, I'm already said you at the first, we need to understand that we are working with a regular. Let's leave on colorful picture. Maybe it will be more pleasant for your eyes. Maybe not. Sorry. And in operating, first you need access to different places. Second, it should be as less valuable, not valuable, but as less expensive as possible. Operating of the aircraft. It means, in particular, that no, aircraft, besides of the most important consumable, no, we have so-called consumables. Yes, what are consumables in the airplane? At the first place, of course, fuel. No, there is nothing to do with it anyway. Some each kilogram, each pound of thrust, it means spending of fuel. It's we can't solve this problem in some another way. But there are also technical oil inside of aircraft. Uh, there are also some special liquids, for instance, in landing gear, in pneumatic systems, so-called hydraulic liquids, and so on. There are consumables which are inside of aircraft, and these consumables should be time to time changed. No, it's a sort of, it's not overall repair, but the sort of one more inspection, which resulted in stopping of operating for some period and continue the no, some repair of airplane, but it's not really repair. It's like changing of those consumables, for instance, or maybe upchanging the protective coatings in the airplane. No, some not significant changes in the airplane in order to support its properties, not even to improve its properties, but to support its properties. And all this should be necessary as no, not necessary, as long as possible. So intervals between those necessary micro repairs should be as long as only possible to save costs in operating. And it's also determined by the designers select what sorts of liquids, what sort of system at all they are going to use. Whether it will be pneumatic systems or it would be hydraulic system in some places, or for oiling system, for instance, what will be design of of these pipes and pumps and what is inside. And all this variable equipment, as I'm already said, you should be operated with this, inspected with this, and demand as much less as possible the attention of this maintenance group, people who are responsible for maintaining the airplane on the airfield. And by now I have counted you 7 group of demands. No, once again it comes about flight performances provided by aerodynamics, demands to the power plant to provide thrust and auxiliary functions, demands to onboard equipment, demands to general strengths, to reliability of devices, and so on and so forth, to correspond to reliability and safety of flight demands, airworthiness demands. Next comes about demands as to the manufacturability of aircraft, and next to the maintainability of aircraft. Altogether it's great, but the most important, it's yet not explained and skipped. And for this we need to recollect what I already once said you. And where is the story I prepared before? This man and his airplane. Так, do forgive me. Time, normal. I hope today I will be not overtime. I hope. Who these people? And what's this equation about? In our country, this equation it's called formula Mozhaysky, and it exists as Mozhaysky formula in our books, in our textbooks about manufacturing. Forgive me, design of airplanes, and so on. We all know, all the aerospace engineers who start studying in our countries, they know this formula with the name of Mozhaysky. And who was Mozhaysky, I have already mentioned sometimes to you. We still didn't talk about history of flight, but some elementary knowledge, some information you got from time to time. Mozhaysky was originally he was Navy officer in Russian Empire, and when he was Navy officer, he regularly watched on board. Then it was you see the years of his life here. It was the middle of 18th century. It's approximately the age of Napoleon war in Europe and results of these wars in Europe and so on, the period of revolutions in Europe, approximately of this period. No, in order you may orient somehow where is it. Because I understand maybe you're not much interested in history of Europe, America, or Africa, because you have your own history of your civilization of China. It's maybe longer than known European history. No, at least let's continue about this. It was the period of quick development of science, of technology, of everything at all. Like humanity jumped with big steps, comparatively to the 10 previous centuries, so-called medieval. It's called period of medieval. Humanity started developing very quickly. And all this atmosphere, let's say, of inspiration of all these technological changes and so on. And the Navy then was practically all with sailing. In order to explain what do I mean, let's use picture to be understood. Oi. It was a period of such ships. And this controlling of these ships, it was important to understand and even to have some intuition how to use these sails in order to provide motion of the ship in their in some proper direction, considering the different wind. And plus to this, the flight of seabirds, which seems like brainless, but they are extremely effective in flight. And naval officer who regularly worked with those practically it comes about aerodynamical knowledges, sales, and watching these birds, he start thinking about realizing the flight by human, whether it's possible or not. No, he was very good engineer actually, and what it resulted in, he created his own airplane. He studied all known concepts of no aerodynamical concepts of flight by that moment. He studied the experience of Otto Lilienthal, and he dreamed about the powered plant, about the flight with engine. Flight does not depend on, no, or at least not so depend on the wind, not due to the wind, like gliding, but flight with engine. And he has created the project of the airplane, and even has got some money, or some portion of money at least, from the government, as far as I remember, to realize this airplane in real. What it looks like, no real photos, of course, we have no. Mostly we have paintings about this airplane, about this event, and his drawings, and the pieces last of this airplane after its unsuccessful landing. No, above the all, it was airplane with huge wing. It has three engines and huge propellers, as you might see. And why it's so important, I'm already said you that this airplane is considered, you see it now better, I hope. This airplane, it was maybe one of the first airplanes which has all the features, all the aggregates of modern airplanes. Modern airplanes of conventional scheme, let's say. And as he understand his problem of his airplane was that it's not possible to provide significant thrust for takeoff. He even used special stage to start flight. You see it's some, like some additional deck under the airplane. And once this airplane take flight, it was first powered flight, or at least it's considered first powered flight. Not all historians agree with this. It was in the March, July. Sorry, do not remember. Uh, let's see. No, he was born in March, and no, it was 1992. According to different sources, right now, no, that is what do you see? Those stories with photos and so on, it's written by me, but some years ago. And they are written here into languages, so, but you know that in your country, not everything is permitted, likewise in our country, by the word. And I do not propose you to open something like this, but you might find it in even your segment of internet, and you might find it in literature that I already passed it to you in books. Some of these books, they contain a lot of historical information. And Mozhaysky made a flight. As it was said, he started flight, and it was a flight around some meters or some tens of meters. But flight has finished unsuccessfully with crash of airplane, and for the next airplane he already has no money. He was just naval officer who is retired. In order to provide this project, he has been retired from Navy, and completely he has family, wife, children. His family completely depends on his money. Yes, and he can't stand. Let's say he can't spend more of his money for this project. So project hasn't developed, wasn't continued. But after this, he start thinking and even wrote something about the principles of aircraft design in the point of view of weight. And actually, the formulas that you right now see and that I'm going to explain, it's not difficult. It looks dreadful, but it's not difficult. It's elementary thing. Uh, but those elementary things, they next resulted in very significant studies and conceptual studies additionally, both aerodynamical strengths whatsoever. So this formula of airplane existence, of aircraft existence, originally was thinked over by this Alexander Fedorovich Mozhaysky. But really, as far as I understand from our literature, the real author of this formula, of these equations, who are called equations of Mozhaysky because he was the first author of this idea at all, of this formula. Another engineer, Viktor Fedorovich Bolkhovitinov, you see, he lived approximately 50 years after Mozhaysky, and he studied this experience of Mozhaysky. Of course, he was well known in our country. And what is the formula I will explain you about, and the last couple of words about Mozhaysky, yeah, I already said it sometimes. What you see right now, you see so-called RC models. And these RC models, they are exact copies. Of course, they are scaled copies, but they are exact copies of Mozhaysky airplane. Some dozens of these models been constructed by amateurs, by real engineers, by those who interested to understand what was the problem of this aircraft. And as well as it was figured out by Mozhaysky himself, and as well as people start understood it since 30 years of previous century. And whatever they understood, it comes about this formula. This aircraft was aerodynamically completely normal, good aircraft. We would not say perfect because for that time, no, for that time it was perfect, of course. But it was normal aircraft, able to fly. What is the problem of this aircraft? What is it? This aircraft had too heavy engine with respect to amount of thrust this aircraft give. And what this equation of mass balance or equations of aircraft existence about? It's very simple idea. Take off weight m0 of any airplane, its weight of structure, what it consists of? Weight of airframe itself. First, you need to some body which carry payload. At all, what just airframe. Its weight of airframe, its weight of payload inside of this airframe. In order it's fly, we need to move it through, we need to transfer it through the air in order to have lift. And it means that need some propulsion system, and it means that we need some power plant. Power plant need to work on some fuel. Even if it comes about electrical engine, instead of weight of fuel, it will be weight of accumulators. So let's call it fuel anyway, whatever kind of engine we are going to use. Once again, airframe, payload, power plant, fuel. What else? Compulsory we have crew, and compulsory we have some equipment which related. We have equipment which is related to the to any airplane, to navigation and communication, to navigation and radio equipment. On other hand, we have some equipment which related to the purpose of airplane, to the payload. In case of passengers, as I already said, seats, toilets, kitchens. In case of military airplane, a weapon, some launching devices, or if that is reconnaissance airplane, some spying devices, no, whatever. Some equipment which is related to it's not immediately payload, but related to payload, payload providing convenience or providing function of the payload at all inside of airplane. Payload may be less or absent in the airplane, but this equipment will be on board permanently. You understand? Well, and what this all about? That no. Now let's go into point drawing again. Dreadful pictures. I should have deleted yesterday. They just torture my aesthetic feelings. Do forgive me those pictures, which made by me. Sorry. What this equation of mass is about? Once again, we have the whole weight, take-off weight of airplane M0, which consists of weight of structure of airframe. Let it be next weight of power plant, weight of fuel, mass, not weight, no, similar on the ground. Next, what did I say? Crew and everything that related to payload, no? Equipment, and payload itself. A very simple idea, actually. Yes, but what is next out of this idea? What is equation of aircraft or airplane existence? Let's divide all these components to M0. Let me repeat it. Divided to M0, and instead of everything is divided onto M0, left side and right side. And in this case, instead of left side, what do we have? M0 divided to M0 equal to 1. And in this case, this equation is rewritten in practically the same way. Wait a second. But another designation. I'm about to start crying. No, not of course. If I have problem with targeting, let's do it like this. Instead of designation that was just mass of structure, mass of power plant, and so on, it's appeared relative mass. It's maybe written like this in some books, maybe written with special letters. Usually it comes about Greek letters. Depends on where you meet this formula, actually. And all these relative weights should be equal to 1. No, like 100%. We have 100%, and all this weight all together, it's takeoff weight of the airplane. What is takeoff weight of airplane would it equal to? I hope you do remember this takeoff weight. No, mass. It's a measure of system inertia, yes, and weight. It's if weight is considered as a force, weight and mass, it's not the same. Yeah? If we're talking about this, it means that we're talking about acceleration of near the Earth, and we're talking about mass, something like this. But if we talk in the most common, in the most simple way, we may say, if we're talking about ground, if we're talking about Earth, not about Moon, not about some another spacecraft, we're talking about airplane near the Earth. We may say mass, we may say weight, meaning the same matters actually in this case. Wait a second. Forgot what do I meant. What do I meant to remind you? What all this is about? What all these masses, all these not relative, all these weights, take off weight of airplane. What it should be equal to? You do remember? Equal to lift. No, actually, takeoff lift. It should be greater. To provide takeoff, lift should be greater. You understand it? Because at this moment, the speed is yet insufficient, and you need either more speed, and it means that much longer runway until you're moving along the ground for 20 minutes, for instance. Of course, it's not a good decision. And another way is to increase lift somehow due to the power plant, high lift devices, and so on. So keeping in mind that these masses, they are equal to lift. And lift is provided due to some properties of your airfoil, due to speed, some flight performances of uh, your aircraft. They are already in project. You decided by some reason, by customer demands, by some ministry demands, for instance, like defense ministry. This airplane should fly, no, cruise flight, for instance, should fly with speed, and next is the speed. Either it comes about 500 kilometers per hour, or it comes about 2 Mach number, for instance. And lift in this case equal to the weight. And the area of wing also, we do remember, yes, it's depends on area of wing that you need to design, yet it depends on the what? It depends on the lift speed that is already known. No, area of wing depends on how it depends on lift. You do remember that in case weight is known, lift equal to the weight, speed we knows, and it means we are able to determine what is area of wing in this case. Area of wing which is not designed yet. Area of wing, area of stabilizer, select the sizes of this wing, and so on, in case we know this, in case we know the weight of the aircraft. But how we may know it? We haven't designed it yet. Yes, but what about these relative values? No, let's imagine that we have some elements, no, some blocks I'll draw here, and these blocks, they symbolize the whole airplane for us, relative weights. Well, do forgive me, maybe it's a bit long. No, and so on. I will not continue to draw these rectangles, which should correspond to each component. Let's imagine that I hope you understood. We have some components, even some more components, and what for these rectangles necessary. To illustrate idea of these relative weights and constancy, let's say, of takeoff weight. Where is it? What, like this? No. Constancy of weight of airplane. For instance, you say that you are going to fly faster. You are going to fly faster. It means that you need less area of wing, no, the same airplane with the same payload and so on, flying faster. Flying faster, it means area of wing is less. And what does it mean? Not like this. What does it mean for you? That maybe you may, I did wrong, that maybe you may reduce the structural weight of aircraft. No, if area of wing is less. It doesn't work so directly, to be frank. Yes, you reduce the area of wing that is necessary if you're flying with another speed. But at this moment, it's appeared that maybe you increase it the weight anyway, because as you reduce the area of wing, specific load to the wing is greater, and it means that you need to provide more strength wing. No, as I already said, you it comes about. It's not direct decision. Yes, it's not so immediately work. No, let's imagine that you reduce it, the area of wing, increase it the speed of flight, reduce it the area of wing. General structure here is general weight of structure is reduced. This relative weight is reduced, and it means that it should be compensated or may be compensated with something else. What does it mean? But look, for instance, uh, no, let it be green is a fuel. And do imagine that someone said, I'd like your airplane fly 1000 kilometer longer. I'd like to increase the range. And how we may do remember that this one must be constant. How we may solve this problem, at least in our preliminary design. How? Something like this. In case we'd like to fly longer, and it means that we need more fuel, at least, yes? We need more fuel, it means that we should compensate it with some another relative value. It means that in order to have another range of airplane, for instance, you need to take less payload. There are some components which are not about to change in any airplane. No, for instance, crew. No, at least two pilots. If we're talking about pilots, and if it's passenger airplane, you have additional crew which working with passenger stewards, depending on the how luxury the airplane, how many seats on that or another class, and so on. The amount of crew is calculated, no, depending on these norms for different classes, so-called international norms, and these things are not about to be changed. If you have to have two pilots, and you will have two pilots, but there are things that may be changed. Either you need to reduce, if you'd like to fly longer, to reduce the relative weight of power plant or relative weight of structure. How we may do it? To change type of engine, for instance, or to change the type of structure. I hope you do remember what we've been talking about. The structure may be of different, completely different types, and really it will looks different inside. Structure may be of thrust type, truss type. Structure may be of beam type, and beam types also at least three general variants available, and they have different weight efficiency. All these matters, all these considerations. They are, no, on one hand, during designing of one individual particular airplane, they are extremely important, of course, especially on the stages of conceptual design. But also such things, they are resulted in appearing of studies, of scientific studies and propositions as to the approaches, how to design airplanes, how to move in that or another direction, what is perspective. And in order not to pull time, not to overload you again, once again, not to torture you with additional information, That may be too much, no, for first years. I have prepared also a couple of diagrams here. No, once again, this equation of mass balances, which actually based on the idea that the whole weight of a craft consists of some components, and actually we may talk about this so-called relative weight of each components, and altogether they are compulsory equal to 100%, or not just usually it's shown like to the one, as to the Greek literas being used for designations of those things. You see what they are designated with Greek literal C. And that is called equation of mass balance, or equations of airplane existence, or one more name, as I already said you, despite it was really developed and described and explained by Bolkhovitinov. It's called Mozhaysky formula named after Mozhaysky because he was the first who start thinking and who start developing this idea that all the elements of airplane, they should have weight that at least able to lift itself, let's say. Now, if engine it's heavy too much and has no enough thrust, we have seen it in simple examples of so-called aerodynamical quality. If airplane is already designed, it has some quality. Where are these polars that I have shown? I have opened all my secrets. Look, here is if airplane concept where it was this beautiful picture was somewhere, да? If it's already made, chosen, you may, let's say, check either full scaled model or better scaled model, not full scaled model. You may check it in wind tunnels. That one is also possible to see in our photos. Where are these photos? Engines, testing, structures. Look how much you already know. And it's just something like my board that I use for illustration, I'm afraid you maybe already knew it before me, maybe. Here is one of examples of testing of scaled airplane in human you see staying not far from the model. Model is rather big, but anyway, it's scaled airplane. Scaled airplane or the model of engine, of course, it's not real engine. It does not exist yet, for instance. Maybe it's some conceptual design of this engine, maybe. And we need to test its outer aerodynamical characteristics according to what we are going to use in our airplane. Da? You see where pointer is blinking now that we have some engine nacelle, pylons, and how these pilots, how they are joined either to the fuselage or to the wing, or it's something more complex like this one. And such a model may be tested in a aerodynamical wind tunnel. As a result, you will have such diagrams like polars. And as a result, you may understand so-called aerodynamical quality, or at least you are able to assess it. So where is it? Not that one. Lift to drag ratio, the ratio coefficient of aerodynamical quality, which practically talks about this. CY/CX, practically it comes about what? Lift to the drag, and as lift is equal to the weight, so what we may say about this force? It's thrust. Yes, and out of this thing, knowing your aerodynamical quality, it's already known what is the necessary, no, approximately, at the first approach, at first iteration, what is approximate value of thrust you need to support this weight during cruise flight. And you may see that you may goes into reference books, into market, wherever, and check what engine do you have, what propositions of engines do you have. And maybe it's a period that engines that necessary for your airplanes, they are too heavy. It means either you may uh, move this airplane, design this airplane, and it will fly, but it will fly without payload because engines are too heavy, or you shouldn't use some another engines. You should use another engines which necessary to create first. No, and so on. And as I already said, Mozhaysky was the one who started working in this direction, and he understood what was the problem of his airplane, at least how he described it. It was problem of heavy engine. That engine has no that steam engine, it had no enough, had low specific thrust to the weight of engine, amount of thrust to the weight of engine. And this equation of existence of airplane, as I already said, it's like start of any design of airplane practically, but it comes in some iterations. It's like by spiral. We do something, next we come back, we detailize it, we change something, and come back and detailize it again and again. But these three stages of design, it's not direct line. It's something like spiral way from one stage to another. For some iterations only, a real airplane may appear. And the very first stage, no, by now at least, what now in nowadays conditions, when we already have information, have statistical data about those relative weights for that or another class of airplane, the very first step of any such design is to collect statistical data to the prototypes, let's say, to the airplanes which has similar flight performances, similar payload, similar purpose above the all, of course, and analyzing their relative weights. Usually, it comes about open information, or at least this information collected by scientific institutions and so on, and relying on this equation of existence of airplane, equation of weight balances, and on other hand, on statistical data about this relative weights of another airplanes, you may do first step on the way of airplane designing. Maybe I'm already too tired because my tongue really barely work already, you see. And to continue to stop this class, to show you finally the diagram which reflect how structures of airplanes in terms of relative weight been changed during the years. No, in different books we might find them for different years. No, mostly you see, I used books that I would get used to since my beginning, since my students' years. What do you see here? Analysis of relative weights. No, there is the same, but not so convenient. It's shown with intersection of curves. With no, but there is more information about real airplanes in this place. Here is like addition and the whole what this axis, vertical axis, the whole weight, takeoff weight, you might say, which is equal to 1. Yeah? And each space between curves, it's like relative weight of that or another component, not component, but that or another system of aircraft. And what we might see that changing of what here is the structure weight, you see, structure of airplane. That weight of structure is changed with reducing gradually. It's due to appearing of and usage of new materials, of course, but it's also due to the appearing of new approaches to structure. No, when people at the beginning of aviation era didn't know anything about structural analysis of airplane at all, and they were not able to calculate to predict something, and been using the materials no by eye, as it's called in our country, approximately. And actually, each flight was a dreadful quest. Whether airplane take off or not, it was possible to calculate whether airplanes withstand the loads in flight, or it will be just destroyed in flight. I'm not joking right now. It's true. Where we have some jump, what you see here in weight of structure, look what it corresponds to. It corresponds to the periods of changing in types of engine, in changing of speeds of flight and changing of type of engines. And next area is the weight of power plants, and also the very similar situation. Look, until it was the first era of aviation, until it was era of piston engines, it was approximately the same relative mass. Next, it's sharp changing because jet engines became more heavy, has appeared. And next, with appearing of new models, with appearing of these turbofan engines, gradually reducing the weight of power plant in the relative weight of power plant in the common weight uh, of the airplane. But in contrary to this, the weight of fuel, look, weight of fuel in beginning of aviation, no? Flight to the next village, and here is flight between continents already, maybe. In general, of course, all those diagrams, like all statistic is the best liar, you know. What and payloads also. Payloads changed over the time, uh, and it's also not true because it should be said that variety of airplane is too much wide. Together with huge airliners like Boeing 747 and A380 and Antonov Ruslan. No, Antonov Ruslan is cargo airplane, it's not airliner for passenger, no whatsoever, approximately the same class. I mean, in line with these airplanes, we have hundreds of different models of structures of so-called general aviation airplane, which are purposed for people, like 15, 20% or less. So it's not possible to say whether structure of payload is growing permanently or not, but we might say that due to structural perfecting and aerodynamical perfecting of structures, of course, we may use more, no, like you do remember those blocks, да? We may afford, let's say, more payload due to uh, perfectizing, due to improving both structure, power plant, and aerodynamics of the airplane. No, actually, aerodynamics already hidden in the structure. Well, once again, what we've been talking about the general principle of airplane design, and I hope you will remember that among to provide flight performances on one hand, yes, we have to provide flight performances of airplane according to technical task given to us, but to provide we have secret aim to provide these flight performances, spending as less as possible both money and time for design, for manufacturing, and for maintenance of the airplane in the future. And for this, we have to consider, to take into account demands of aerodynamics, demands of considerations of power plant, consideration of uh, onboard equipment, what sort of equipment to use, heavy mechanical devices but reliable, or modern light smart computer devices, but which are subject depends on electricity and subjected to electromagnetic effects, for instance, no, and so on. Will not repeat it. And next, we're talking about demands of reliability, safety, durability. It means airworthiness of demands of airworthiness of airplane, Next, compulsory considered during designing of airplane, few the manufacturing demands to save money during manufacturing of each airplane, and maintainability demands to save money during maintenance of airplane to make operating of airplane as cheap as possible. But on the first place, on the zero place, always it's like crazy idea of any designer providing of minimum of weight whatsoever, providing of minimum of weight on all the stages, culture of design, culture of manufacturing, and in maintainability either, in maintenance, not maintainability, in maintenance also, providing of minimum of weight. Each gram of extra weight of airplane, not according by the word to these equations of aircraft existence, amount of fuel, relative amount of fuel, actually usually for middle range planes, it's around half of weight of structure. And if you have overweight in structure, no, 1 gram for, oh, let it be 1 kilogram. 1 kilogram, it's too much, of course. If you have 1 kilogram of structure overweight of the airplane, maybe due to extra layer of paint or extra thick protective coating, due to poor accuracy of mechanical machining, for instance, in parts, due to whatsoever in the problem of design or manufacturing, uh, each next kilogram, extra kilogram of weight, it's half of kilo of fuel for each flight. And how many flights it's do during year? No, even if in a day, 150. Yes, uh, 150, and how years we're going to operate this airplane? Maybe 20 years, maybe 30 years. Now tendency is to improve the reliability of airplanes, their fatigability up to 60,000 of flight hours. And do think about the minimum of weight in order to save money next in money, environment, and so on in operating. So on the first place, equation of Mozhaysky or equation of airplane existence, it's the first step of any airplane project design. And maybe in one in practical classes, I hope we will try to do something like this together with my explanation and next individually. I hope we will. Right now we finished. Sorry, I again take a bit more time than necessary. Goodbye.